Okay, so today we're going to handle the first practical part of enterprise networking security and automation, which is ENSA practice PT skills assessment. This one, remember, we will handle the ITN SRWE part 1 and part 2 in the previous videos. So I'm just going to click this one and let it load, and I'm just going to take assessment. I have the latest version of Packet Tracer and open Packet Tracer executable, and so I'll just give it some time so that we can load. Okay, so this is the topology that we have here, that we need to implement some technologies, and here are the instructions. So let's open the instructions. As you can see, here are the instructions. So what I'll do, I'll just click on dock. Alright, so the instructions are on the left and the topology on the right. Okay, so let's do a little bit of this one like this. Okay. Alright, so guys, I'll take my time to read it very fast so that we can begin configuration. And here is the addressing table that we are supposed to use in our topology. So we are required to complete the configuration of XYZ COP network. You are not required to configure host addressing. You will practice and be assessed on the following skills. So what we are required to implement are just configuration of Spf version 2 routing. We need to customize the Ospf protocol. We need to configure static NAT, configure dynamic NAT with PAT, and configure various types of access control list, and also configure router with NTP as a system time source. And also finally we need to back up the USB image to TFTP server. Alright, so step 1, use a process ID of 10 for Ospf activation on all the routers. Activate Ospf by configuring the interface of the network device in the branch 1 network where required. Okay, so this is the branch 1 network. Alright, okay, and activate Ospf using the network statement and inverse mask, wildcard mask on the routers in the SQ network. Okay, understand that. And also note that for the purpose of this assessment, please enter the network statements in the following order. Alright, so we need to start from router 4. Alright, okay, so let's activate Ospf on router 4 first. Okay, so the first step requires us to advertise the networks. Remember, we've been told to use a process ID of 10 here, and as you can see, the devices cannot communicate unless we implement a routing protocol, and we've been told to use Spf here. So for example, in router B, we're going to advertise how many networks? This one and this one. And for router 2, router C, we're going to advertise how many networks? This one and this one, right? And so on and so forth. So I'll begin advertising the routes in the networks. For example, in this router, I'm going to advertise this network and this network. Let me click on the router so that we can go very fast. Enable config T, then router Ospf, a process of ID of 10, and then a network of network to be 192.168.11.0, a wildcard mask of 0.0.0.255, area 0. Okay, then another network is this network here, which is 10.10.1.16, So another network is just a minute. I'll go very fast. 10.10.1.16. Wildcard mask of let me check, this is 29. So 29 wildcard mask will be 0.0.0 sorry .0.7 a wildcard mask. So just a minute, let me just add again 0.0.0.7, then area 0. Okay, then do right. Okay, so I'll just copy this, the two, then open notepad. I'll just copy the two, copy, then I open notepad and paste. I remove this. Okay, so I say router Ospf 10. The first command should be enable config T, and then exit the interface, the protocol interface, then do right. Okay, so close this router, come to this one, enable config T, and then I say this is 22 here, 22, this one. Okay, so I'll copy and I paste here. Alright, so I proceed to this router, which is connected to how many networks? It's connected to 3 networks, this one, and the one here. So I click on it, enable, then I come here and modify the networks. For example, this is 10.10.16, that is this is 10.10.0.236. okay, and the other network is let me just see, is 192.0.2. so there we have 3 networks, which is the first one is 192.0.2.12/19. that's a network, so I'll just change here 192.0.2.112/29, which is equivalent to this wildcard mask, and we go. Yes, another network is this one, 10.10.0.236. copy 10.10.0.236 236 wildcard mask of /30. /30 notation will give us a wildcard mask of 0.0.0.3. okay, then I copy all this and I paste to this router here. So I proceed to these routers on the corporate network and advertise the respective networks. So for example, this one will advertise this network, and this network. I'll do that very fast. This one is 240, 248, okay, 240, and this one is 248. okay, alright, so copy all of them, come to this router here and paste. Okay, then we move to the these routers here. This one will advertise this network, this one and this one. So 244, then what? Okay, just let me just open the notepad. Let this one to be 244 and the first one to be, we have 240 and 240 for this one and this one. Okay, 240 and 244, and the last one is 192.168.33.0. okay, so it's 192.168.33.0 and the /28 notation. /28 notation is equivalent to a wildcard mask of just a minute, 15.15 0.0.0.15. okay, copy, come to this router, enable and paste. Okay, then finally to this router here, so this router is connected to 244, 248 and 44 and 55. So it's connected to 4 networks. I'll copy this one and paste twice. So the second one is 44 and the third one is 55 and dot 255 and the other one is 244 and 248, 244 and 248, 244 and 248. I think I made a error somewhere when I was configuring this one. Advertised wrong network, but I'll just go to correct it. Copy, come here, enable, then paste. Okay, so close that one and come back to this router and correct this one. This network is not there, this one, it is not there, so we'll do it again. Enable, then I modify that network, this one, it's 240, not 2, it's 240. Good, so do right. You will see they will form adjacency with the upper router, this one. Okay, so basically we've configured Ospf on all these routers, right? Okay, so let's proceed. So I'll go to my topology and check where router 4 is. So this is the router 4, right? Okay, I'll click on router 4 and come, enable and config T. Alright, so we are required to activate Ospf on these interfaces. How many? 1, 2, 3. Alright, so let's just say interface serial 0/1/1. Let's say IP Ospf 10 area 0, because we've been told to use a process ID of 10, right? As you can see here. Okay, exit. Another one is 20. Let's use 10 first, 10, and do the same. Exit. Another one is 20, and do the same. Exit. And you do right. Okay, alright, so we move to router 5 and configure the same. I'll close, then move to router 5, which is this one. Yes, enable, then config T. We need how many interfaces? 3 also. Interface serial 0/1/1, then IP Ospf. We need to activate Ospf on this interfaces area 0. Okay, exit. Another interface is 10010, then the same command, exit. As you can see, they have formed adjacency with router 4. Okay, alright, so exit that one. Then we finally move to gig 000, gig 0/0/0. Hit enter. Interface, then we configure the same parameter here, exit, and do right. So let's move to router 6, which is this one. Enable config T. So let me check all the interfaces. Okay, so for router 6 we have how many interfaces? 4 there. Serial 010, serial 011, and gig 000 and gig 001. Okay, so interface, let's start with gigs. Gig 0/0/0, hit enter. IP Ospf 10, area 0, exit. Gig 001 now, IP Spf 10. Then we move to serial interfaces. Interface serial 0/1/0. Then same parameters, exit. Then finally serial, as you can see, they have formed adjacency with the other router. So the other one is serial 111, hit enter. 0111, then same parameters, and as you can see, it has also formed adjacency with the other interface of the other router. Okay, so we are done on that part. Now we move to step 2, which is to configure router IDs. Okay, to which routers? Router 1, 2, and 3. So we go back to these routers here, branch 1, to configure a router ID. So click on this router here, it's router 1, enable, then say config T, then router Ospf 10, then router ID it's 9.9.9.9. okay, the first command that you should enter is that make the router aware that it's using Ospf protocol with a process ID over ID. Make the router aware that it's using Ospf protocol with a process ID of 10. Then you specify the router ID. Okay, then you exit and you do right. So we move to router 2, which is this one, and configure a router ID, config T. So router Ospf 10, then router ID is 8.8.8.8. remember, a router ID is always a 32-bit number, like IP address. Okay, so it should be 4 octets. Sorry. Then move to router 3, which is this one. Enable config T, and then router Ospf 10, then the router ID of 7.7.7.7, exit, do right. Okay, so what's step 3 now? We need to customize Ospf operations. Part A, configure router 1 with the highest Ospf interface priority so that it will always be designated router of the multicast network. Remember, as you can see, this is a multicast network because they are sharing same Ethernet network here, same switch here. So this is a multicast network, multi-access network. Okay, they're sharing Ethernet source here. Okay, they switch, so they need to have DR and BDR, designated router and backup designated router. Okay, so we are told to configure R1 to be our designated router. So let's do that very fast. So I'll click on router 1, and the first thing that we should do, guys, we check which interface is connected to the Ethernet source. Which interface of this router is connected to the switch here, so that we can configure it with the highest priority. Okay, for example, for router 2 it's this interface, which is gig 001. Then for router 3 is gig 001 also, but now for router 1 it's gig 000. So we are going to configure highest Ospf interface priority on gig 000 on router 1. So I'll click on router 1 and say interface gig 0/0/0, hit enter. Then we're going to configure the highest. Remember, the priority ranges from 0 to 255, but we can't use 0. We start using from 1, so the highest is 255. So I'll just say IP Ospf priority to be, let me just query. Okay, it's 255, right? All right, and you exit. Okay, so let's move to step 2. We're still on router 1. On router 1, configure default route to the ISP using the exit interface command argument. We need to configure a default static route. What's a default static route? A default static route will be in use whenever there is no routes found in the routing table. Okay, when there's no matching route found in the routing table, it's always 00000. So we need to configure default route here to the internet. I hope this is the ISP, or is there any other ISP apart from that one? There's no. So we need to use the exit interface, which is this one. This one is serial just a minute, serial 011. Okay, now let's configure default route. How do we configure default route? Just say IP route destination 000 with any subnet mask. So guys, this one means any IP address with any subnet mask should be routed through serial 0/0/0. Let me check the interface again. Yes, serial 011. Okay, and hit enter. Default route without gateway, if not point to point, may fail, but this is a point to point, as you can see, from this router to this router, so there is no problem. Just submit that one. Alright, so automatically distribute the route, automatically distribute the default route to all the routers in the network. How do we do that? How do we automate the distribution of default routes to all the routers in the network? Very easy. Let me show you. So in this part, we're going to configure Ospf to advertise routes to its neighbors, to advertise default routes, to its neighbors. Okay, Okay, so how do we do that? So I'll just click on router 1 still, and remember this the default route that you configured. Okay, so I'll just say router Ospf 10. Then there is a concept of default it's default information originate. Let me query another information. There's no other information. So guys, this information here, which is default information originate, the default information originate will advertise Ospf config the default route to other neighbors. So using this command here, we are configuring Ospf to advertise default routes to the neighbors. Okay, so exit. Alright, so we are done with part C. Let's go to part D, which is to configure hello and dead timers on the interfaces that connects R1 to R4 to be twice the default values. Okay, R1 to R4. Okay, so we are going to configure default hello and dead. We're going to configure hello and dead timers to this interface, which is this serial 010. Let me check again. Yes, it's serial 010. So let's do that very fast. Okay, so we just enter interface serial 010. Just let me check again. Yes, it's 010. So let's configure default. Let's configure hello and dead timers. Okay, so we are required to configure hello and dead timers value to be twice the default values. So let's start with hello timers. So just say IP Spf hello interval to be twice the default value. The default value is always 10, so twice is 20. Okay, now let's configure dead timer or Spf dead interval to be twice the default value. The default value is always 40. Now twice is 80. Exit. Alright, so we're going smoothly. We have no any complication. So part E here says configure Spf router so that default cost for all Gigabit Ethernet will be 10 and the cost value for fast Ethernet will be 100. We are required to configure Spf routers so that the default cost for all gigs interface to be 10 and fast Ethernet to be 100. So we can start with this one, and we'll just see which it had 2 Gigabit Ethernet interfaces, which is gig 000 and gig 001. Alright, so and this one is okay. I can't see a router with fast Ethernet interface, but let me just continue checking. I can't see any router with fast Ethernet interface. I can't see any router with fast Ethernet interface here. So let's proceed to configure Gigabit interfaces. So I'll start with the router 1, and to configure default cost, so let's say router Spf 10, and now we say auto cost because we need to configure default cost to these interfaces. Auto cost, let me just query auto cost reference bandwidth that we query again, it should be from 1 to this value in terms of megabits per second. So we need to configure it megabits per second, and you can see here it's 10 and 10 Gbps. So let's convert this into Mbps. So we multiply this one with 10,000, which will be 10,000. Okay, really? So interface will be 10, the cost, and this one is always been Gbps. So when you turn Gbps to Mbps, you get 10,000. Okay, that's good. Let me just see. For Spf reference changed, please ensure it's consistent across all other routers. Good. So guys, we need to configure this to all other routers. Configure, a copy, do right. So we go to this router. I'll just open notepad very fast and say router Ospf 10, then we paste this one. Remember the value came from 10 Gbps to 10,000 Mbps. Okay, then we say do right. Okay, so we copy to all other routers. Start with this one. Just a minute, let me add enable and config T so that I don't need to configure all. Enable config T. Okay, copy all, copy, and I paste here. Good. Come here, sorry, I come here and I paste, and I come here also and I paste, then to this router I paste, finally to this router I paste. Okay, so let's move to part E, which is to configure Ospf cost value of router 4 interface serial 001 011 to 50. Router 4 is here, so just go to router 4 and say exit here, interface serial 0, let me check again, serial 1, then just say IP Ospf cost to be 50. Okay, exit and do right. Okay, so finally part G, we need to configure Spf so that routing updates are not sent into the networks where Ospf updates are not required. Okay, alright, so we need to configure these routers so that routing updates are not sent to interfaces where they are not required. Okay, so this is very easy. We just need to use passive interface. Which is very easy. So let's start with router 1. Okay, so when we analyze this topology, guys, first we want to identify which those interfaces that we don't need the routing updates to be advertised. For example, in router 1, we don't need a routing update from the ISP to our router 1 here, because you know the ISP router might have a very huge routing table from all the routers in the world, so we don't need to advertise that updates to our router here. So this is the passive interface that we need to configure here, this one, so that no updates can come from the ISP. Okay, so I'll go to router 1 and say exit router Ospf 10. Then we need to configure passive interface to be which one? This one, serial 011. Serial 011. Okay, exit, do right. So we proceed to the other routers. Let's proceed to router 2. So for router 2, this interface will receive updates from this router and this router, but this interface will not receive any update because you can see it's only connected to the host devices. So let's configure this interface as a passive interface. Exit router Spf 10. Okay, so which interface is this one? Just a minute. It's gig 000. Okay, I'll do it very fast. Passive interface gig 0/0/0 and do right. Okay, we are done with that one. We move to this one also. This interface will not receive any update, so it's gig 000. Exit router Ospf 10 passive interface to be gig 0/0/0. Exit, do right. So let's move to the other side. For example, this router here, router 5 here, this interface will not receive any updates, but this one and this one will receive updates, so we configure this one as a passive interface. So exit router Ospf 10 passive interface to be, let me check it again, this one is gig 000. Okay, gig 0/0/0. Exit, do right, close this one. Then router 6. For router 6, this one and this one shouldn't receive SPF updates, so exit router Ospf 10 passive interface to be, let me check, gig 001 and gig 000. Okay, 000 and 01. Exit, do that. So let's move to the last router, which is router 4, this one. So for router 4, let me just check how many interfaces are there here. There's no any other connected interface, right? So we are good to go. We have completed step 3, and now we can proceed to part 2, which is to configure NAT. Okay, all right. So in this part of the practical skills assessment, you will configure static and dynamic NAT at the network edge. Okay, somewhere here. Configure static NAT to translate. So we are required to configure static NAT to translate the address of the partner server on LAN 1 to public address of this one. Okay, that's step 1. So where is the partner server? Yes, the partner server. So we are going to configure this router to be a NAT router so that it can translate the address of the partner server to a public address of this one. Okay, so let's proceed. So let's click on this one. Okay, how do we configure NAT? IP NAT, NAT inside source to be static, and we need to translate IP address of this server, which is the source, and it's as you can see, it's 192.168.11.100. okay, So let's just go up and click. So it's 192.168.11.100.2, a public address of this one. Can you see this one? 192.168. Dot 0.2.115. As you can see, this is a public address, while this one is a private address. Okay, so we just hit enter. All right. Okay, now let's configure interfaces. Let's match the interfaces to the NAT that is just configured. For example, this will be NAT inside and this one will be NAT outside. So which interface is this? Gig 000. So just say interface gig 000 IP NAT inside. Exit. And the other interface will be IP NAT outside this one. It's 0 serial 011 interface serial 011 IP NAT outside. Exit. Do right. Okay. Okay, so we are done with that one. We move to step 2. Configure dynamic port address translation. Okay, create access list 1 to allow all addresses in this network to be translated. Okay, that's very easy. It's very easy. Create a NAT pool 1. It should use address range, this one. Okay, all right. Configure NAT to dynamically use the addresses in the pool for all traffic and entering the company network. Remember that it's likely to be more than 3 hosts will be accessing traffic on the network, on the internet I mean. Okay, so basically we are still going to configure NAT here. So let's proceed. So I'll click on router 1. Okay, the first thing that we have been told to create ACL, access control list. So I'll just say access list 1 permit which network? This one, to allow all addresses 192.168.0.0 and a wildcard mask of 0.0.0 add no .255.255 because the subnet mask was 255.255.0.0. Okay, all right. So let's create a pool. The second step is to create a pool. I'll just say IP NAT pool, a pool name of pool, and that's like that, -1, and the pool should consist of 192.168 .0.2.116 to 192.0.2. There was a problem here. There was a problem here. As you can see, 192.0.118. So they missed 2 here. So I'll just correct it. 2.118. Then a net mask of. So here we need to identify the net mask. As you can see, we'll only need how many addresses? Public addresses 3, which is 116, 117 and 118. So the subnet mask will be a subnet mask that can contain 3 hosts. For example, 252.252 almost always contain only 2 hosts. So it should be just a minute 248. Okay, 248. So just write 255.255 192.168.255.248. Subnetting, very easy. If you don't understand subnetting, kindly search about it and hit enter. And now guys, we need to match this pool to the access list. We need to bind the pool to the access list, which is very easy. Let me do that. Okay, so IP NAT source IP NAT, just a minute, static IP NAT source access. I'm forgetting something here. Let me just try to remember. Oh, okay, I now remember. IP NAT inside source list 1, access list 1. Okay, then bind it to pool, this pool here, pool 1, then overload. Okay, dynamic NAT with part. Hit enter. And now guys, we need to configure an interface to as IP NAT inside. Which one here? Or this one. So we can take serial 0, 1, 0. So I'll click on the router again. Interface serial 0, 1, 0. IP NAT inside. Exit. Do right. Okay. We've configured step 2. So what's remaining basically is to part 3, which is configuring ACLs, access control lists, and part 4, which is to manage the devices. So let's proceed to configure access control list. Configure ACLs to meet the following requirement. Use host and any keywords whenever possible. Always explicitly configure the default deny condition when it is to be used as part of ACL functionality, so that it can be logged when the condition is met. Okay, we don't need to specify the default deny condition if it is counteracted with permit IP any for this assessment. All access control lists should be placed in the most efficient location according to the guideline specified in the curriculum. Part 1. Create a named standard access list to explicitly prevent all external traffic accessing telnet lines on router 1. Okay, name the list VTY block. All addresses on this one should be allowed to access VTY lines. Verify the list works as specified. Okay, so we are required to configure ACLs on this router to prevent external traffic from accessing telnet remote access, and at the same time we allow traffic from this network to access the VTY line. And you know, we should name the list VTY block. So let's click on this router and begin configuring the first part. So I click on the first router and I say IP NAT standard IP access standard. Let's give it a name of VTY block, VTY -block as specified here, VTY block and 8 enter. Then we say we permit which network? This one, 192.168.0.0, a wildcard mask of 0.0.0, sorry, 0.0.0.255.255, and we need to deny any. Okay, so exit the interface, exit the line, I mean. Then we move to line VTY, 0 to 15, access, how do we say, IP access list, IP access list, access cluster, I mean, VTY block, VTY block in. Okay, exit and do right. Okay, do show start. Alright, so let me just check how we've configured. Okay, alright, okay, so I'll close this one and proceed to part B, which is to create a numbered access control list to prevent all hosts on LAN 1 from accessing LAN 2. Use 10 as a number of access list. So let me just check which LAN 1 and LAN 2 here. I can't see LAN 1 and LAN 2. Okay, just a minute. So yeah, it's like LAN A and LAN B. Okay, so where do we configure the access list? Where will you configure the ACL? We can configure ACL here or here. It depends. Okay, for example, we can configure ACL and match it to this interface so that it can be executed before it goes out of the router, or we can configure ACL so that the traffic will be dropped when it has arrived on this interface of router 3. And because we need to allow other traffic, we should configure the access list here and match it to this interface. So I'll click on this router and say enable config T, then access list 10, right? Access list 10, deny, just a minute, deny this network here from getting into this LAN. So the network is 192.168.11.11.0, subnet a wildcard mask of 255.255.255, 0.0.255.255. Okay, sorry, I've just made a problem. So just a minute. Oh, I think I forgot deny here. I forgot deny there. So I'll just say access list 10 deny 192.168.11.0 with the wildcard mask of 0.0.255.255. Okay, alright, and access list 10 permit any. Alright, so we need that access list to be applied to which interface before it gets into our router? This one, gig 0.0.0.1. okay, so interface gig 0.0.1 IP access group which one? It's 10. Okay, let me just query 10. Okay, then I query again in. Good. So exit the interface and do right. Okay, so what's remaining? Part C. So part C says create an extended numbered access list that will prevent traffic from LAN 4 network from accessing HTTP service running on a utility server. All other traffic from LAN 4 hosts should be able to access the network. Number the list 101. Okay, here is now we're going to configure a extended access list, okay, to prevent traffic from LAN 4 from accessing HTTP service in utility server here. So where is LAN 4? LAN 4, where is LAN 4? This one, LAN D. So we're going to prevent traffic from this one from entering this utility server. Okay, all right, so basically then all of the traffic from LAN 4 hosts should be able to access the network. Okay, we are only going to prevent traffic from accessing HTTP service on this server, but all other resources will be allowed. Okay, so let's configure the extended access control list. So we need to identify where we'll configure the access list. For example, I think it's the best at router 6 here, so that all traffic that is coming from LAN D should be inspected, and in case it will match the access rule policy, it will be dropped. Okay, so we can use router 6 with this interface. Okay, so let me just say enable config t access list 101 deny any host from accessing which host device, from accessing which device, this one, which is let me check IP address 192.168.33.14 192.168.33.14, then equation TCP www, because we don't want it to access which service, HTTP, or we can use port 80. Okay, let me check again. We have a problem somewhere. Let me access list 101 deny TCP any host. It should be TCP any host. TCP any host. Remember, HTTP is always a TCP service, okay, with port 80. So access list 101 deny any TCP host. No, it should not be that. It should be TCP any host. TCP any host, that one. Okay, all right. So access list 101 permit TCP any. Okay, so let's apply that the access rule to this interface, which is gig 000. Okay, so interface gig 000 IP access list access group 101. Let me query in. Okay, so exit and do right. So guys, we are done with part 3, and now we go to part 4, the last part, which is to manage network devices. We are required to configure network time protocol, configure router 5 to use utility server as its time source. This router 5 here. That's very easy. So I'll click on router 5 and begin configuration of NTP. So router 5 enable config T, and NTP server should be just a minute, NTP server, just a minute, NTP server should be, just a minute, this one, utility server, which has an IP address of 33.192.168.33.14. okay, so do right, we're done with that one. And now finally we need to back up the image file on the router 5 to utility server, which is very easy also. Okay, so I'll just click on router 5. Okay, exit. We need to back up IIS image on router 5 to the utility server. Okay, so first of all we need to check the location on the directory of the IIS image. How do we do that? Show flash. Okay, just a minute. System plus directory, we have length, name, service. Okay, so this is our IIS image. I'll copy it, this one here. So what do? We just copy, flash to TFTP, and the file source name, this one, okay, the one that I've just copied. Hit enter, and address or name of remote host. The address was 192.168.33.14. IP address of the utility server. Okay, destination file, yes. So let's just wait. So as you can see, it's done, the saving is done. So what I'll do basically is just to submit the test, see how much you've gotten, and I believe every technology that was asked we've implemented. So I'll just click submit task and wait to see how much you've gotten. We passed. So thank you guys for watching. Please subscribe. Bye.